Alright, hello everyone again. This is your teacher, Mr. Brewer, again. Continuing the discussion of 3.3 in the book. So we left off with number 1 here, verifying trig identities. So now I'll just move on to the next example. So this is example number 2 in the book. So this is EX2 in the book. On the page it's example 3, that's because I did number 1, and that was my example 2. So if you're looking at the book, this is example 2. So we're going to establish this identity. So the first thing I notice is that I have sine squared of some theta plus cosine squared of some theta, and that equals 1. So I know this looks very much like the Pythagorean identity, so I know that has to do something with the way I'm going to attack this problem here. Alright, so first thing I want to do is I want to move this square to the outside. So what I mean by that is basically just do this. And this is an equivalent expression to sine squared of negative x, sine of negative x squared. And I'm going to do that with the cosine as well. So I have cosine of negative x squared, and this is equal to 1. So this is just rewriting. Okay. My next step is to use the fact that sine is an odd function. So sine is an odd function, so that becomes negative sine of x, and this is still squared. And then I'm going to use the fact that cosine is an even function, so this becomes cosine of x squared, and this is equal to 1. So these are my even and odd IDs. Cosine is an even function, sine is an odd function. And now I get to square these two, so I'll go ahead and do that. So squaring them gets rid of the negative. A negative times a negative is a positive. Plus cosine squared x equals 1. So this is squaring. And lastly, now I have my Pythagorean identity. So sine squared x plus cosine squared x just equals 1. And that equals 1 on this side. So this is Pythagorean identity. So there you have it. There's that one. Okay. So the next one. This one here, I believe, is example number 3 in your book. And this one's kind of a doozy. This is when we first start to factor things. So when you're factoring in Pythagorean identities, it's very fun, as in frustrating. So I noticed the sine squared and the cosine squared here, so I know this has something to do with the Pythagorean identity. So first thing, just like with the previous problem, I'm going to rewrite sine squared of negative theta as sine of negative theta squared. So let's go ahead and do that. Sine of negative theta squared. And we're going to minus, and same thing here, cosine of negative theta squared. And this will be over sine of negative theta minus cosine of negative theta equals, and instead of writing this out every time, you can just say right hand side. So that equals the right hand side. Okay. So notice how I kept these as sine of negative theta as opposed to negative sine of theta. So I'm going to do the even odd function stuff all at the same time, which will actually be this step right now. So this was just rewriting the expression or the equation. That's what we did there. Now I'm going to rewrite these using my even odd identities. So sine of negative theta becomes negative sine of theta, and this is squared. And then this will be minus cosine of theta, and that's squared.
Good morning.
Morning. And this will be over, so sine of negative theta becomes negative sine of theta minus cosine of theta, because that's an even function, so that doesn't change it. So this equals the right hand side, and this is even, odd IDs. Alright, so now I get to square these two. So I'm going to go ahead and do that. Actually, I'm not going to square these two. So what I'm going to do is I'm going to factor this using the difference of two squares. So this will be, so imagine this is like x squared plus y squared.